All right, we are taking a look at Unit 5, Kinetics, and we are on the last topic, which is on catalysts. We will explain the relationship between the effect of a catalyst on a reaction and changes in the reaction mechanism, how those relate together. So a catalyst is a substance that changes the speed of a chemical reaction without undergoing a permanent chemical change itself. So the catalyst itself doesn't change throughout or after the process is over. It lowers the activation energy of the reaction by providing an alternative reaction pathway. So this is where we start to see reaction mechanisms occurring more and multiple steps occurring for a reaction. So here's an example. H2O2, that's hydrogen peroxide, it will naturally decompose into water and oxygen. So without a catalyst, it's an extremely slow reaction. You might have had a bottle of hydrogen peroxide, brown bottle, in your medicine cabinet at home for years, and likely it is this reaction has taken place somewhat, but not a lot because it's very slow. And that's another reason why they're in a brown bottle. The sunlight would also speed up the reaction. But we could speed up this reaction to get that oxygen gas bubbling out by adding a catalyst. An example of one is bromide ion, and it can be added through adding HBr, hydrobromic acid. So if we added that acid to our solution of peroxide, then the hydrogen bromine would split apart into its ions. It would be aqueous. And then we'd have that added H2O2 that's reacting. And in the process, the bromine would stick together. They would give up each of their extra electrons and then become a Br2 molecule. All right. Then that Br2 molecule would again gain 2 electrons from the hydrogen peroxide and turn back into bromine ion. So we can see that the bromine ion is present at the beginning as a reactant, and it's present at the end as one of the last products. And it is unchanged. Even though it goes through a change during the reaction, it becomes Br2. That's an intermediate, and we would take that out. But the bromine itself, what we put in is exactly what we get out. The bromide and hydrogen ions are reformed and are not permanently changed. So we also see the same thing happen with the hydrogen ions. Those are just kind of spectators hanging out, not really doing anything. So we get our same catalyst out of the reaction that we started with. When we look at a reaction profile for a catalyzed reaction, it's going to change the activation energy. So we can see in the graph here, the uncatalyzed reaction is the red line on the top, and it has a high activation energy. Remember, our activation energy starts at our reactants and goes all the way to the top, of that hill, okay? So that's our activation energy for that uncatalyzed reaction. With the catalyst, that's the blue line, the reaction takes a different multi-step pathway, but with a lower activation energy, which is easier for the reaction. So it's the same reaction of the peroxide plus bromine and hydrogen. So the first step has a pretty low activation energy. The second step would be our slower step. It has a higher activation energy, but overall those two are lower than the uncatalyzed reaction. So even though it has to go through 2 steps, they're both lower in activation energy, and we get a faster reaction. So it says, remember that a reaction like this can be represented as a rate law. So we can always write a rate law for a reaction. And since the concentrations of the reactants aren't changed, the catalyst only affects the value of the rate constant there. Okay, so our catalyst affects our rate constant for a reaction, and we would write our catalyst as part of the rate law as well. Now, there are different types of catalysts Many catalysts can also work by assisting in the orientation of the reactants to increase the collision frequency. So that's another way that they can act. So one type of this is called a heterogeneous catalyst. So it's usually a solid, like a solid surface, maybe a metal that provides that surface for the reaction to take place on and helps the chemicals to react. So it might be that it allows the atoms to attach to it, gets their bonds broken, and then the atoms can come together and create a new product. A homogeneous reaction mixture, or excuse me, reaction catalyst, is when the reactants and the catalyst are in the same state of matter. Okay, homogeneous means same state of matter, heterogeneous meaning different states of matter. So that's why we're getting that solid. So it's just that they're same state of matter. The last reaction with the aqueous hydrogen bromide and the aqueous hydrogen peroxide would be an example of that, where they're both in the same state of matter. And the last one is an enzymatic reaction. So enzymes, you might have heard of enzymes in biology. So typically in biological processes, we use enzymes. An enzyme is a specific protein that aids in a chemical reaction. It helps to break the bond, for example, in sucrose to form glucose and fructose in digestion. So we can see that up here. This large molecule is sucrose, and it has this bond that we want to break, and it will break it into glucose and fructose, into those two different sugars. So that bond is harder to break. So in the body, we've developed a protein called sucrase. And this is a whole big long chain of atoms, big long molecule that's folded up in a specific way, and it kind of fits like a lock and key. These molecules fit right into that sucrase enzyme, and then the enzyme helps to break that bond. Then we get that glucose and fructose. All right, so where the enzyme accepts the molecule is called its active site, and it's kind of like puzzle pieces fitting in. So we have lots of enzymes in our body, and they do different jobs. So this one helps us digest sucrose by breaking it down. But there's lots of jobs of different catalysts in our bodies that are enzymes. So in conclusion, our catalysts are not consumed in a chemical reaction. What we put in is what we get out. They provide an alternative pathway for the reaction to take place, so we get that reaction mechanism from them. And they speed up the reaction by lowering the activation energy of it and speeding it up. All right, so that's the main things about catalysts. This is a short section. You just have some practice multiple choice questions. And that's it for this unit. Thanks, guys.